Hello, I'm Adrian from 905A Robotics, and this is my robot explanation video for my robot concept. So first off, we have the intake. I have a 2-motor 5-to-1 gear ratio on the intake. And it works something like this. So the first thing that I found really important on my intake was the ability to intake straight into the scoring on the logo, so it could just go straight and really quick and smooth. So the way that I achieved this was I changed the roller to an X roller that allows the intake to push the ball higher. And when I'm doing it, it doesn't go fast enough, but when the intake spins, as you can see, it goes high enough. And then, of course, it also intakes while the catapult is down, so it can also just do this, and it can intake over the ball because of the roller. And for my back wall, I did a flexible back wall, as you can see here, and this allows the ride to be this allows the ball to go up the intake smoother, as the back wall is flexible. And then for the bottom, for the funnel, the guide, I made a flexible guide like this, so that it would be able to intake into the corners, which I will demonstrate later. Basically, as you can see, the guide works very well. So if I just toss the ball in, then it will go up. And then, yeah, that's about it. Next up, we have the catapult. So the catapult works something like this, and it is used to score on the high goal. The mechanism behind it is a T-fling. So when you spin it once, there's a standoff that pulls the catapult down, and if you look over here, there's a ratchet. And then if you can see here, when you spin it again, the standoff releases it. Oh wait, I think it'll be clear on this side. So catapult goes down, as you can see, and then spin again, and spin again, and it releases the catapult. And then, yeah, that's it. So next up we have the back roller, and the back roller is used to score on the logo, and it works something like this. So the way that I designed this was the ball could really smoothly just roll from the catapult straight into the roller to be scored. And the way I did this was I had the L pieces on the catapult. These beams are flat with the ramp at the back that feeds the ball into the roller, so the ball can just roll down something like that, and then when I spin the intake, it scores. So the way that I powered it was I did a PTO, so a motor share with one of the catapult motors. So if you look closely, if I spin the roller, then this gear does not spin this big gear, and this is the gear that powers the catapult. But if you look closely, the big gear doesn't spin. But when I spin the motor the other way, this spins the catapult. So then the catapult will go down. But if I don't spin it that way, then the catapult will not move, and then this chain that feeds. This is a chain that's connected to the roller, and the roller spins. So the only downside with this is when I spin the catapult. When I spin the catapult, as you can see here, give me a second. The roller, it also spins, but the way that I geared it, it will not go anything because the roller is spinning backward. And that's it. So next up we have the drivetrain. So the drivetrain that I made was a two motor, a 2-to-1 drivetrain using the Omni wheels. I use the Omni wheels because it reduces the turning friction and it allows the robot to turn off the walls. And the reason why, as you can see here, I powered all 4 of the wheels was because at the very beginning I only powered the front wheel, but then because the robot was rear heavy, then the robot would tip something like that, and then so if I drive backward and drive forward, the robot would lose grip, as most of the weight is on the rear wheel, not the front wheel, which is right here. So, and that's why I did it a 4-wheel drive. And then if you look back here, I have the liner, and the only reason why I use this, the triangle brace piece, is because it is light and strong. As my old liner was made out of 2 beams. Here, let me show you. It was something like this. So instead of having one big piece, it would be 2 beams and then one of the corner connectors. So the reason why I switched out of this was, 1, this is heavier, and 2, it can break easily. If I just squeeze here, because it's connected by pins, it'll easily break. But on this piece, it is light because it is only one big triangle, and because there's no connections, it's way stronger. But the only trade-off is that it is not symmetrical, but as long as your driving skill is alright, then it should cause no problem, and the trade-off is worth it. So now I will be demonstrating to you the intake. So as you can see, when I intake the ball, that's basically when you drive into the corner, these arms, they flex so that the intake is able to reach the corner, so that when you intake the ball is fully inside the intake when it reaches the corner. And then because it's flexible, a lot of times it also works somewhere like here. When I want to take the ball, it flexes like so toward the wall, so that the intake will still be able to drive and reach the ball fully. Because on my older robot, when you weren't allowed to do that, when you intake the ball, it wouldn't be as consistent, because the robot would only be able to drive until like here, and it would be harder for it to intake the ball. My current robot can, because the intake is also slightly improved, but on the older robot it would just do that. But now you're able to drive inside completely. And yeah, that is my demonstration of the intake. Good guys.